Hey guys, welcome to Developer. This is Ayush, and today we are discussing about DFAs in this video. I think basically my plan over here is to create two or three more videos on this topic, as my aim is to finish it off with an implementation of DFAs. So basically the last videos are gonna be means on this topic are gonna be the implementation of a deterministic finite automaton, automaton singular, automata plural. Right. So, okay. With now with that out of the way, let's dive right into it. So, DFA stands for Deterministic Finite Automaton. As you can see on this wiki page over here, right? Um, Basically, as you can see it already, it is a graph. It's a graph. For those who know graph, it's a graph. So, what is a DFA? A DFA is a state machine. It has a set of states, a transition function which governs the transition happening between these states, a set of input symbols which will be used as input to these transition states, along with the states themselves to move you over between these states. Yeah, basically that's pretty much it about what a DFA is and what it has. And yeah, there are two kinds of states in a DFA. Um, Accept states and reject states. So this state right over here is 0. It has double circles. It is an accept state. States which are not marked with double circles are reject states like S1 and S2 over here. Okay. Which will is accept state and reject state, what they actually do, what they are, we'll see it when we discuss some examples. I have some examples. I'll discuss them in a short while. Okay. What type of state is gonna be is it will depend on the pattern you're trying to match basically with this DFA. DFAs are used for string pattern matching, and depending on the kind of pattern which you're looking for in your input string, your DFA will have different number of states, different transition function, and a different set of accept and reject states. There can be multiple accept states, by the way, more complicated DFAs. Uh, so, but let's go over some simple DFA examples to understand how it all works. Okay, so here's my example which I do out for you guys. Um, yeah, okay, let's go over this very first example. But yeah, so let me give out a disclaimer before I start with the examples. Let's be very clear that our aim in this video, or this series rather, is to implement a DFA in our code. So we would not be discussing all these very exciting nitty-gritties of DFAs right here. Although that might interest some viewers, it is unfortunately beyond our scope here. So let's limit our discussions to basics of DFA and try implementing DFA. We wouldn't be doing that in this video, but yeah, in a future video, definitely. So, having said that, this right here is a simple DFA which accepts only strings which has A's. Um Consider it like a strict parent who only accept A's and good marks from their kids. So if there is anything else, they'll reject you. Well, hell, okay. Now, this DFA, so as you see, the state Q0, states are these circles. So the state Q0 over here, it has this arrow which comes from nowhere. So there exists only one such state in a DFA, and that's the initial state. That's where you are when you enter a DFA and start your pattern matching. That's the root of all your transitions. I mean, everything starts from there. Start matching patterns from there. So, as I said, this is a string which accepts only A's. So you give it to some anything else apart from A, and it will reject the string. So you start from Q0 as it's marked as the initial state, and we know this because it has an arrow coming out from nowhere. Give it A's, it will be staying on Q0, and Q0 is marked as an accept state. So keep on giving it A's, it will keep on accepting you. You give it P, it goes on to Q1, and no matter what you give it now, A or B, it will stay on Q1. So this Q1 is kind of a dead state. Uh, there is no transition happening out of Q1 to any other state, and once you reach Q1 you are stuck there, so it's a dead state. We set out for matching only strings which have only A's between them, kind of very boring match, but uh, again, so that's what the question over here. We will be only matching strings which have only A's. Give me anything else, I'll reject you. And that's what this DFA does. Right. Let's go over this second example real quick. Let me mask out this first example. Nice. This second example over here, well, this DFA accept only strings which ends with A's. When constructing a DFA, every uh, character you encounter, we presume it to be the last character of our string. So we model the DFA, the whole layout, the backbone, the structure, the states and transition and all, everything, while keeping this at the back of our mind that every character we encounter could be the last string, very likely be the last string. So let's see how this assumption works over here in our favor. We want to accept only strings which end with A's. So, well, Q0 is the initial starting state over here. You give an A, we move on to Q1 state, which is an accepting state. Since we were assuming that this is the end of the character, end of the string rather, we will accept you because you gave us an A. Well, in case it might not be the end of the character, end of the string, if it's still A's which we are encountering, we keep on accepting the string. If it is something else, we move on back to Q0. If it is not A, we move on back to Q0. If B is the, so basically in this set which we are considering the input alphabet, A and B are the ones in our input space. So if you give us any other thing apart from A, we move on to Q0. Keep us giving that, B in our case, we stay on Q0. The moment you give us A, as we are assuming that this is the end of the string, every time you give us A, we are happy to end it over there. We will accept the string. Give it B, we will not. So this is the DFA which accepts only strings which ends with A's. Yeah, okay. So now as we did some basic examples, let's quickly discuss some uses of DFAs. Since it's basically used for pattern matching in strings only, so its applications usually revolve around that. DFAs can be uh, like, let's go over some examples, okay? DFAs can be used to make regex engines, which can do a lot of complicated pattern matching well. So and a lot of complicated DFAs backing those regex engines at the sitting at the very root, at the very core of these regex engines. Again, these regex engines can be made from not only DFAs but NFAs, which are non-deterministic finite automata. Let's not get ahead of ourselves and keep discussion closed only to DFAs. We'll not go over what NFAs are and what they do in this series. Uh, okay, so it can be also used in NLP applications, natural language processing, where you try finding out stop words and whatnot to make some really good and complicated stuff. Hmm. Like a chatbot, which will, which can basically talk and give some basic answers to you. Yeah. Okay. Not really an expert in that field, but just kind of skimming it over because that's something which it can be used for. Okay. Since we saw that it is working on streaming input, as in where you don't know, you don't have a knowledge of what comes next. Everything which comes, you assume it's the end. So since it works on streaming input inherently. It can be used to verify incoming bytes via some network connection, do some authentication stuff. Like if your network packets the incoming string, the incoming set of bytes, and if it terminates with a particular character code, we'll accept uh, uh, we'll accept your network input. Otherwise, we would not. Okay, okay. So classical use case. It's used in compilers which transform your high-level code into machine understandable or any intermediate language. Lastly, the fun thing. It's used in games too. Well, games basically are an amalgamation of all these things, some technical nerdy stuff. Well, so as I said, it's used in games. So it's used in games like to model animation states, to model NPC or AI behaviors, like the behavior tree. If you hit them, how do they react? If you laugh at them, how do they react? If you give them a chocolate, how do they react? If you hit, well, you get it. Yeah. So let's get uh, pull up the Unity doc for Unity's animation controller and discuss the animation use case real quick. How a DFA can be used for modeling an animation state. So, well, this right here it's not exactly a DFA. It has states, it has transition between these states, it has a starting state, but there are no accepting or rejecting states. Well, it's a subset of a DFA. Depending on what you want uh, out of your game, you can uh, model these animation states accordingly. We'll go over what this thing does. This is the example which is present on the Unity doc for animation controller. And this right here is our starting state, initial state. So the game starts, entry. The player is grounded. Yeah, by the way, this I have no clue what the animation state is represent for what character, if it's even the player or something else. But yeah, we can assume that it's of a player, and we can go over it with that assumption. So the game starts, the player is grounded. You press, I don't know, maybe spacebar, cross, or A on your gamepad. You go from grounded to the jumping state. Now, while you're jumping, uh, your player encounters a ledge, so he goes on ledge hanging. You can maybe for ledge hanging you play an animation clip which shows him holding onto the ledge, grabbing it while his 2 feet are dangling, something like that. So while jumping, you encounter some ledges. At the very right moment, you press some buttons and you grab onto a ledge. You start ledge hanging. Player changes its animation state from jumping to ledge hanging. Now, your ledge detection can happen in a number of ways. Your player, the player collider collides with some ledge collider. The ledge's collider is in the climbable layer, so the player basically can grab this ledge and yeah. So you do ledge hanging. Now, from ledge hanging, we see there are transitions to and from the falling state. So it can happen based on logics like you held onto the ledge for more than 2 seconds, you start falling, and while falling, you encounter another ledge, and you press a button, and then you grab onto that ledge again. I mean, the ledge just underneath the previous one which you were hanging onto, and you start ledge hanging all over again. The same rules apply. You go between these two. Now there are no more ledges to hang on to. You start falling. You you fall, then you go grounded, and maybe from you encounter a ground, the ground breaks, and you start falling again. You go back to falling state. So, well, I'm uh, just inventing these transition states out of thin air here. I have no clue what these transitions are governed by. But as clueless as I am over here, and you might be too, we'll go over this transition, how this all happens, what's the logic for transitioning between these states, where is it written, how to write one, all of these things in the next video, where I'll show a player character and his animation state of a game, and we'll see how this thing works, and it's real fun stuff, believe me. Okay, easy but fun. Yeah, I mean, from ground you might even go to die state. Maybe your health bar lowers every time, and once your health bar is lower down to zero, you die. Every time you hit the ground, your health bar loses 50 points, and maybe you lose a life point, whatever, and you die. Die is kind of the dead state over here, as you saw in the first example. Uh, this one, yes, this one. Q1 was the dead state. Similarly here, die is the dead state. There is no coming back from death. Okay, so this was DFAs. What DFAs are, what they do, and where they're used. We ended with an explanation of a fun example, uh, and I'll go over what actually this example or a similar example works. We'll see some cool animations and uh, all of these things in the next video. So please wait around for the next video, um, where we'll discuss these things. I'll see you in the next video. We'll go over DFAs again. We'll discuss the fun aspect of it with animation, with an example of animation controller. That's it for this video. See you in the next one. Bye bye.